and smart cities not only have to be smart, they have to be safe. That's why we are going to talk about the challenges that cities face when they are affected by different kind of shocks, especially natural disasters, but man-made disasters. It's important to understand that disasters are not natural, especially when they are a function of three variables: the probability of the occurrence of several types of events, earthquakes, floods, landslides, but also they depend on the different elements that are exposed and the vulnerability of those elements to be affected to the different type of shocks that we are going to be talking about. Those factors are not static. They can be improving, they can be changed, depending on the institutional and individual capacity of the different stakeholders that take decisions and act in development-related activities in our cities. Resilient cities will be defined depending on the capacities of these exposed systems and their components part to anticipate, absorb, adapt, or recover from the different effects of hazardous events, including the preservation, restoration, improvement of its essential basic infrastructure and the different functions. So we are going to have 4 panelists today. Our first panelist will be Professor Frederick Krimgold, Director of Disaster Risk Reduction Program in the Virginia Polytechnic Institute and State University. And he is going to talk about tools for initial assessment for physical systems, urban systems, and administrative capacity in small, medium, and developing cities. Professor, the floor is yours.
Thank you very much. I appreciate very much the opportunity to participate in this panel, and particularly to participate in a meeting which includes so many of the important stakeholders in this topic, the major corporations and the city management, as well as researchers like myself. Thank you. The material that I'm going to present today has been contributed by a number of participants representing a collaboration of 3 universities, several companies, and material from several cities around the world. So I have to get started and move quickly. The brief introduction will be addressing what the problems of resilience are in complex systems like urban areas. The next will be a series of case studies illustrating various aspects of critical infrastructure, vulnerability reduction, and resilience enhancement. And then finally, a comment on resources and emerging markets in this area. The basic definitions, I won't go through in detail. Anna already mentioned the definition of resilience, but basically we're dealing primarily with the physical systems. Thank you. The physical systems and the administrative capacity of municipal governments to manage those systems and to effectively incorporate newly available technologies that make the monitoring and management of interdependent systems feasible. And finally, I'll talk about the tools that are being developed specifically to address assessment of resilience. Here, I simply want to illustrate that the consideration of resilience related to particular incidents like earthquakes and floods, etc., begins before and continues long after, so that the resilience time frame is much greater than the incident time frame that we've dealt with in risk reduction or disaster management in the past. And so we're going to be looking at both the analytical tools that allow us to estimate and invest in vulnerability reduction and resilience, and also the facilitation of recovery, which is the other half of resilience. Basically, this is a small city, and part of our emphasis is looking at the capabilities of small cities and dealing with the complexity of urban systems. And we see here simply an illustration of the complexity of the systems, primarily transportation, energy, water and sanitation, and communications, as they are represented in a city here of less than 50,000 population. I want to make a point also about urban services and about the interdependencies of systems regarding just one particular function, in this case, the fire response system, and to make the point that if we have an incident, as you see indicated in red on one side of the slide, there is an immediate dependence on communications capacity in reporting. There is then communications capacity dependency in mobilizing resources. Then there is a transportation system dependency on moving the firefighting equipment to the site of the fire. And then there is a very strong dependency on water systems to actually fight the fire. So we see that in accomplishment of any particular function, we have a critical relationship and multiple dependencies, as well as the fact that in each case, we would see that the communications function, the traffic signaling function, and the water supply function are dependent on electricity. So this is simply an illustration of the complexity we face. The key questions that we face in risk management are really quite obvious here. What are the risks that we need to deal with? And in this case, we also, in the case of resiliency, are looking at unanticipated risks. We're looking at the capacity to respond to circumstances which we're not able to base on analysis of the past, but rather we need to develop mechanisms that are flexible enough to respond to unanticipated threats. We also have to look at what's exposed, what the populations are, what the assets are that may suffer damage. And finally, we have to analyze the priorities for investment in risk reduction. The interesting thing that we found in our work is that while we can analyze and understand the physical systems in each of the 4 sectors I mentioned, we also have found that one of the greatest impediments to reducing loss and to enhancing resilience is the rather static nature of municipal administration, and the fact that municipal administrative structures are not well suited to taking advantage of recently developed technological capacities, or well developed to deal with complex interdependencies between systems. We've heard a lot of people talking about breaking silos, but we have to understand that it's not enough to break the silo. We really have to replace it with a system that effectively relates what was previously in the silos. The cases that we have studied in the United States, which have been of particular value, include the Washington metropolitan area, the Hampton Roads area, which is a very large military concentration, and most recently we've worked in the metropolitan area of Nashville, Tennessee, in which we've been able to look at the development of a comprehensive metropolitan system for the monitoring and coordination of the principal infrastructure systems. This is simply illustrating the functioning of the electric power grid at a certain point in the post-disaster situation. Moving on to a broader set of case studies, we have been collaborating. As you may have noticed, there are several authors listed on this paper. We've been collaborating with EQS, which is a university here in Barcelona that's taken a leading role in the development of assessment tools and management tools for dealing with municipal resilience. And they began in a very fruitful collaboration with Barcelona back in 2007, following several significant incidents, and have developed the fundamental tools for the assessment and management of resilience. The primary issues, the first study was something dealing with the assessment called the SSS project, and the second, which dealt with this administrative problem of how we actually address the complexity of the infrastructure issue, is under the name of TISU, and it's actually a board which brings together all of the major stakeholders to allow for the development of consensus in management of interdependencies of infrastructure systems. This is really pioneering work and has led to further examples carried on by EQS in Tremp, which is a small rural town nearby with a population of only 7,000, but still benefiting from the same analysis. And then expanded to a regional level in La Guerocha, where looking at an area which encompassed 21 smaller towns, the same principles of resilience assessment were successfully carried out, and now a follow-on project to develop a situation room is under consideration. We're also collaborating with the École des Ingénieurs de la Ville de Paris, where similar work is being carried out, particularly with reference to flooding in various parts of France. And here is just an example of a study of flood risk in Paris, and the same multi-sectoral analysis of infrastructure vulnerability, and a similar methodology developed for reduction of interdependencies. Now, the parallel development to these activities is something that we have noticed, independent of the resilience work, is an emerging tendency of cities of various sizes to contract out the management of infrastructure systems and other urban services. And we see this as a very interesting opportunity for the transformation of municipal management to incorporate the kinds of technologies that will be described by other members of this panel. And here are very quickly a few examples. This is work that's being done by Ferrovial in Birmingham in England, where they have begun by taking over responsibility for roads and road-related systems. And then in Peterborough, also in the UK, the list of services has expanded so that they're able to incorporate within a management contract the coordination and the technological updating of practices for these services. And finally, in Sheffield, which is also in the UK, they have evolved this corporate managed infrastructure coordination to an even higher level and a more expanded set of services. In the US, we have several examples of the similar phenomenon. The one I point to here is for a small town of only 30,000 people in Louisiana, in which the city has chosen to contract out the primary public works services as well as a number of administrative and financial services. So we see the possibility here of a new relationship, a new public-private relationship for urban management. Oops, what's happened now? Yeah, okay. And now just to review some of the tools that have been developed, and these are primarily tools that have come from academic research And I would say that this academic research would always profit from greater collaboration with the primary industrial partners, but in the funding process, it doesn't always work that way. This is just a rough outline representing the process developed by my institution, Virginia Tech, in collaboration with the American Society of Mechanical Engineers. It's called RAMCAP. And this is an illustration diagrammatically of the Hazur tools that have been developed by EQS and are now being provided by a startup company called Optiseats. And in fact, though you can't say it necessarily from these diagrams, these models are based on similar principles, and though they vary in their emphasis, they provide comprehensively a new approach to the assessment of resilience. And here is a representation of the methodology developed in Paris by the École des Ingénieurs de la Ville de Paris. And these resources are being brought together and provided to the marketplace by startup companies. Finally, I'd like to say that, well, is there a future for dumb cities? I don't think so. The challenge of complexity and scale is approaching all municipalities at all sizes. And what we are beginning to see is that it's not only a question, I think an earlier speaker in another session said that municipalities have to embrace complexity. I think we also have to think about reducing complexity. In some ways, taking the example of Alexander the Great in Gordian, where he was asked to untie the knot, and he took his sword and chopped it. And I think that if we begin to think of approaches to reducing the scale and reducing complexity and beginning to look at bottom-up rather than top-down techniques of infrastructure management, that we may have more fruitful results. The other thing that we've seen is examples of the sort of command control models of massive centralization with surveillance and centralized decision making. And in fact, these approaches are not actually compatible with our social, political, and moral values in many cases. And we should be sure that we don't simply develop technologies that facilitate control rather than facilitating participation and independence. It seems rather that we should be looking for technologies that facilitate distributed, autonomous self-reliance at a smaller scale rather than the embracing of complexity. The last thing I would like to say is that, as I mentioned earlier, we see this marketplace developing for resilience in which we have a number of participants. And I think we're represented here in this panel. One is the traditional service providers that are focused on one of the verticals in the service provision model. And they are expanding to consider resilience in the context of their traditional work. Another is the, whoops, are we getting the next slide? Oh, well, we'll do it without a slide. And the other is a new set of companies, primarily in the information technology area, where they are specializing in providing the communications links to pull together the distributed functions of the traditional service providers. And the third, which I think is most interesting, is this set of companies that are focused specifically on resilience and on developing the tools and the capacity to provide resilience in existing systems. And they are, in many cases, spin-offs from universities, but there's clearly a new opportunity for partnership between these emerging companies, the traditional companies, and a new relationship between the public and private sector to accomplish municipal management. Thank you.
Thanks, Professor. Now we move on from the assessment to the application, and our next speaker is Mirko Masi from Abertis Telecom from Barcelona, Spain, and he's going to talk about telecommunication infrastructure for resilient cities.
Good afternoon. So
Play yours. Play here.
with this mouse.
Yeah, it's not.
So this afternoon, the idea is to speak about the resilience of a city or city resilience from a telecom infrastructure point of view. Abertis Telecom, the company that I represent, we are working actively in the smart city environment from the perspective of the areas of influence that are quite traditional in the city management, but also we are working in the security and emergency network to provide communication to organization or first responders. What we see is that we have different technological plane in the organization of infrastructures in a city that are providing, in a way, more or less the same function or result. That is, transport information, collect information in a control center, having gathered this information to take some decision that from the smart city point of view could be improve the efficiency of a city, but from the resilient point of view could be use the resources in the critical moment of a catastrophe to try to respond in the best way, save lives, and improve the situation. Well, the paradigm of transmitting the information to the smart brain to take the decision is the same as in a human body. Here, the communication are really important to provide reliable information. If you look at the definition of a resilient city, taking the definition from the organization of resilient city, we have different aspects that should be taken in consideration when we design the infrastructure for this purpose. The idea is to have diversity alternatives. Our colleague here that will speak later probably present another application about how to have alternative, for example, in mobility, when you have a traffic jam. You have to have redundancy because the information or the inputs to the smart brain, the control room, have to be on time and have alternative to reach it. Then you have to have also feedback, capacity adaptation, and integration with the environment. This is important because if we are not able to design all the infrastructure with these criteria, what we will miss then is probably the fact that in the moment we need the information, then we will miss it, and we are not able to take the proper decision. From our point of view, you can see the smart city as I told you before, three technological planes. We have the data gathering layer, where we have on the left side, you see, normally we have parking, lighting, waste, mobility, environment. We have several type of sensor and technology that allows to get up the information. We have a lot of video applications, service applications that are developed, driven by market that are pushing in this direction. On the right side, you have the PPDR, that are all the activity that are related to the first responders that are devoted to control, help in situation of emergency. And we have, in most of the city, networks devoted to the police, the fire brigade, and so on. But there is really not a link between the two worlds. We have, in the telecom or communication plane, a lot of technology transmitting the information with different design criteria, different reliability. And then we probably have a smart brain that today is not integrated, but we have a lot of municipalities speaking about application to collect the information, process it, and present to the citizen, to control room where probably the city manager has to take the decision, or to private company, open data, and so on. So we have two worlds. One is driven by the market, the interest of saving, improving the use of resources. The other is that a lot of activity done and infrastructure built to preserve the safety in case of emergency or in the daily life. In all these planes, we are applying some criteria in terms of modularity, redundancy, and so on. But the reality is that there is not link. And this is an issue that is probably has to be taken in consideration by the city managers or the mayor of the city, because we have a lot of infrastructure in the city, but the day we probably need the information to take some decisions that are related to the resilience of a city in case of catastrophe, we will miss this information. As an example, here you see on the bottom, you have a sensor in the parking, or cameras using fiber optic, using the PSTN network, WiMAX to connect sensors spread over the city, video that needs some capacity that can be offered by the wireless network. And then we have on the right side, normally the trunking and digital technology that provide communication on the daily life of the first responder, and that have to be available the day where a catastrophe or a disaster is happening. All of these have different application. The reliability of the information and the criticality of the information is different, but they have a common scope to provide on the top the information to take decisions. Some time ago, our company was involved in a project called CORIST, funded by the European Community, where the idea was, in case of catastrophe, a disaster, inform and advise, warn the citizens in order to react in the proper way. This is already 4 years ago, from the end of the project. At that moment, the idea was to take information from probably the legacy system, the 112, some information from citizens that can call, and then from that information coming in case of this warning, inform the other people that were not involved in this detection, and inform them with sirens, radio, TV, mobile phone, and so on. Probably today, the same project would have a different focus, since we have a lot of more information available. We have the smartphone, we have a lot of sensor, and this is probably the challenge we have. Try to use all the information to drive the best decision when the resilient city has to prove that is in fact the case. Conclusions. I try to... we have a lot of infrastructure driven, as I said, with the new move in the market. Today, a smart city is a must. We have a lot of infrastructure built. We have a lot of operational platform built. And we have also the need to provide the right information at the right moment. And probably what we miss is the criteria to ensure that all this information is linked between the, let's say, the resource management optimization and the need to provide the right response in case of catastrophe. One of the issues that we propose is to consider that the mix of technology that we have today can be taken in consideration to provide a complementary activity or complementary effort in terms of providing the information today, for example, from the first responders organization to the city municipality in terms of improve the management, or vice versa, use a lot of information the city has today to better improve and to fix the contingency plan or the activity when a catastrophe or hazard is happening. So the conclusion for us is, let's take in consideration this opportunity, because the day that this catastrophe will happen, will not probably not have the link that we are speaking about. And this link is very easy to be taken in consideration because it's in the hands of the city managers that today are doing a lot of effort, and this is probably a little step that we can, together with the research organization, put together and help in having better and safe cities today. That's my conclusion. Okay.
Thank you. Thank you, Mirko. We will move now on to see one application in the city of Medellin, Colombia, about intelligent systems to operate transport in case of normal situation and in crisis.
Bueno, muy buenas tardes. Yo les voy a hablar en español. Para empezar, estamos en las ciudades inteligentes. En este evento han salido 3 palabras que creo que es importante que las tengamos antes de iniciar. Hablamos de eficiencia. Para nadie es tema de controversia que hay que ser más eficientes cada uno de los sectores. Integración. En integración tenemos que ser integrales hacia adentro del proceso, es decir, cada sector, movilidad, energía, acueducto, y hacia afuera, es decir, interconectar esos sectores. Y sale la tercera palabra muy importante y creo que es el fin de una Smart Cities, que somos los usuarios. Si los usuarios y los ciudadanos no estamos integrados en este proceso y no recibimos los beneficios, nuestro actuar, que es el que va a dar la eficiencia en estas iniciativas, no tendrá los resultados esperados. Yo les voy a mostrar la iniciativa que en Colombia, la primera iniciativa sobre un sistema inteligente de movilidad para los ciudadanos. El título habla de 3 cosas, de las TIC, los sistemas de comunicaciones y tecnológicos, de las ITS, que tienen un gran avance, los sistemas inteligentes de transporte, por su sigla en inglés, y la información georreferenciada. Creo que si los problemas pasan en los puntos, en la ciudad, hay que tener todo muy georreferenciado, porque el lugar donde pasan los eventos condiciona la actuación en cada evento. La agenda que vamos a preparar son 3 puntos. Vamos a hablar de un resumen cómo es la movilidad de la ciudad de Medellín, qué es el centro de control, qué es el cerebro de ese sistema inteligente, algunos logros y unas conclusiones y retos. La movilidad en Medellín, podemos hablar de que en Medellín, según la última encuesta que se hizo Origen Destino, sigue siendo la caminata y el bus los medios de más uso en la ciudad, seguido por una masificación importante de la motocicleta. En Medellín tenemos un tiempo promedio de viaje de 43 minutos y una velocidad promedio de 34 kilómetros por hora. La población de Medellín es aproximadamente 2.4 millones de personas en un área de 380 kilómetros cuadrados. Tenemos una gran tasa de mortalidad por accidentes de tránsito. Si la miramos en el entorno latinoamericano, como tasa por habitantes, estamos en un 4º lugar de estas ciudades principales. Si lo miramos por tasa de motorización, de pronto estamos en un lugar menor. Pero es uno de los principales problemas que tenemos en la ciudad y una de las premisas con que se creó el sistema inteligente de movilidad: salvar vidas y mejorar la calidad de vida. Y creo que ese es el objeto de todos los sistemas de redes inteligentes para las ciudades inteligentes. El centro de control de tránsito, les decía, el centro de control de tránsito, entonces ahí lo vemos, hay unos componentes ITS de por sí que nos permiten empezar a leer la ciudad y a entender qué pasa en la ciudad. Esos sensores que en caso de una emergencia podamos tener la información tal cual que nos permita la tecnología para poder tomar decisiones. Digamos que cada día en la ciudad nos estamos preparando para un gran evento. Cada pequeño evento que pasa en la ciudad tenemos que prepararnos para hacerlo bien, porque en caso que pase un gran evento es donde falla todo. Lo decía el anterior expositor, las comunicaciones es un problema muy crucial en esos momentos, de haber una redundancia para poder que esa información siga llegando y que esa comunicación hacia los usuarios se siga dando. Los componentes, ahí los vemos, en la ciudad tenemos unos componentes, no tenemos la cantidad de sensores que tienen acá en Europa y en algunos países de América, pero la premisa es, vamos teniendo los sensores que necesitamos y vamos a entender cómo funcionan y cómo nos ayudan. Cuando le hagamos la máxima explotación, vamos a seguir creciendo y entendiendo dónde necesitamos esta información. ¿Dónde la necesitamos? Donde afecte a la masa de la sociedad, donde nos ayude a tomar decisiones inteligentes. Los componentes son, muchos que acá, cámaras de fotodetección para el control. Digamos que el centro de control tiene dos premisas, control y cultura. Entonces, para eso tenemos cámaras de fotodetección. Tenemos circuito cerrado de televisión con software inteligente de detección de automática de incidentes y con analítica. En el centro de control de tránsito no creemos en las personas que miran pantallas. Pensamos que mirar pantalla es una carga para un operador que le resta su capacidad de operación. Tenemos el control de flota, los vehículos tienen a bordo computador que nos permite visualizar varias de las variables de cómo se comporta el transporte público. El tema de optimización de semáforos para saber cómo se comportan los vehículos en las intersecciones y poder programar efectivamente los semáforos o en caso de una emergencia poder reaccionar. A este año no hay un control de la semaforización directa, pero esperamos que el próximo año ya tengamos ese control para poder actuar sobre los tiempos de los semáforos. Los tableros informativos y la web 2.0, que son dos de los sistemas con los que hablamos de la cultura, hablamos de la información al usuario, en la que a través de los paneles les llegamos y a través de la web 2.0 intercambiamos información, el usuario vuelve parte activa. Y por debajo vemos la capa de georreferenciación. Todos estos componentes están ahí georreferenciados. Y más que incorporados, que es muchas veces lo que pasa en muchos centros de control, que hay muchos componentes, pero cada uno está ahí, no hay interrelación, las variables de uno no le aportan al otro, y menos a un operador que tiene la responsabilidad de actuar, y más en una emergencia donde actuar es muy difícil, si no le damos a la tecnología la capacidad de que nos haga un análisis y nos proponga algunas situaciones de actuación. Entonces nos importa la operación integrada. Entonces lo que le decía, para la operación integrada nos basamos en que es muy importante detectar. O sea, los sensores tienen la función de detectar, de verificar y de actuar. El centro de control es más que una operación, tiene la planeación, la coordinación y la gestión de la información. Es decir, hay que planear qué pasa en la operación, hay que operar con lo que viene y hay que hacer un post para analizar qué pasó, qué hicimos bien y qué vamos a dejar de hacer. Lo que les decía de las alertas, es más importante gestionar alertas que gestionar imágenes y gestionar datos. Los datos los tenemos que procesar y volverlos inteligentes, que nos ayuden a saber cómo se comporta nuestra ciudad y podamos actuar sobre ello. Los logros, entonces los logros más importantes son, se redujo la accidentalidad en un 18% alrededor de las cámaras de fotodetección, una reducción importante sabiendo que nuestra ciudad es de mucha accidentalidad. Los tiempos de respuesta, se redujo aproximadamente en 4 minutos la respuesta ante un evento en la ciudad, es decir, la capacidad de estar con el ciudadano cuando tiene un evento, y eso traducido en tiempo de congestión, le calculamos que a la ciudad le ahorramos aproximadamente 6.8 millones de horas de congestión en el año, lo que es calidad de vida, es tiempo que dedicamos a otros temas y no a viajes en la ciudad. Incidente negativo, en estas centrales de emergencia generalmente a la central prioritaria el 80% de las llamadas son negativas, para nosotros en tránsito solo el 20% es negativo y logramos reducir al 17%. Eso es ganarle tiempo al recurso humano que tenemos también destinado a ese trabajo de atender los incidentes. Y lo más importante, Medellin les mostraba la tasa de mortalidad, es muy alta. El año pasado logramos la cifra más baja en los últimos 5 años. Logramos reducir 16% las muertes por accidente de tránsito. Calculamos 32 vidas que pudieron seguir su camino. Con eso yo creo que es la mejor y la más grande logro que puede tener un sistema. Las conclusiones, entonces nosotros pensamos que así como estamos invirtiendo en tecnología, que lo estamos haciendo muy bien, tenemos que invertir en el capital humano. O sea, el capital humano tiene que estar entrenado y habilitado, y el entrenamiento se da todos los días, pero yo para dejar historia de esto necesito recopilar y hacer procesos que respondan a ese tema día a día, de manera que para un evento grande, donde la ciudad está implicada porque haya un deslizamiento o una inundación que afecte varios sectores, el sector de la movilidad es el que va a facilitar que cada uno de estos sectores, el de la energía, el del agua, pueda llegar al sitio y hacer la intervención. Actualmente una de las integraciones en que estamos es con salud y con el sistema de alertas tempranas de inundaciones, en el que nos compartimos la información, pero más que los datos es la información, es decir, ellos procesan lo de ellos, hacen su análisis y nos entregan la parte ya procesada para que nosotros tomemos decisiones con esto. Entonces les decía, fortalecer las competencias humanas, implementar modelos de asignación, tenemos que empezar a trabajar más en la simulación. Sectores como el eléctrico y otros sistemas ya tienen modelados los sistemas y trabajan mucho en qué pasaría y cuál es mi plan. Creo que nos toca construir esos planes. Así como lo decía algún día el general MacArthur, haga el plan pero no lo cumpla. Pero si tengo un plan, hice un estudio que fui capaz de sustentar y tengo condiciones para poderlo variar. La participación de los usuarios sigue siendo importante. Nuestra red social que más importante es el Twitter. Tenemos una cuenta que empezó en el 2009 y hoy cuenta con más de 68.000 seguidores, que es la oportunidad de gestionar a los usuarios, a las vías y a las zonas donde queremos que estén, para que usemos óptimamente la red vial. El modelo de seguir construyendo ciudades lo dijo, aquí está Darío del banco de Embark, y él lo dijo, es seguir construyendo vías, es seguir tratando de pensar que para reducir el problema de obesidad me subo la talla del pantalón. Yo tengo que aprender a manejar lo que tengo y a tomar acciones sobre lo que tengo. Y lo otro muy importante, creemos que tenemos que seguir trabajando con la academia, con las universidades, para calcular y mitigar los riesgos que tiene el evento de ciudad y calcular cuál es el beneficio de que yo tenga que responder rápido a un evento, rápidamente, y eso en lo económico, social, porque es muy difícil sustentar un proyecto de estos donde no hay beneficios económicos directos. Digamos que el beneficio es la mejora de la calidad de vida, la mejora en la salud, y eso tiene que reivindicarse de una municipalidad, de un servicio de salud a un servicio de movilidad. Tiene que ser un servicio integral de todos los componentes que tiene como misión una entidad municipal. No siendo más, les agradezco la atención.
Okay, thanks, Roberto. We welcome now Yasser Helmi. He works with Cisco Smart Connected Communities, and he's a business development manager. And he's going to talk about the platforms that they are using for resilient cities.
So, good evening, everyone. So I have the pleasure of presenting the last 12 minutes of a very long 3-day conference. So I hope you still have the energy for the last 12 minutes. I certainly do. It's been an excellent conference. I was just speaking to a colleague yesterday. There's something about the Barcelona event, because they have all of these all around the world, and I've been to several of them. There's always an energy, and this is the 3rd year we participate here. There's always an energy in Barcelona which is extremely tremendous. I mean, just looking at the room, and this is the last 12 minutes of a long 3 days, as I say, and you know, we still have plenty of people that are interested. So I'm gonna dive straight into this. So at Cisco, we are a communications company, for those who don't know us, and we provide connectivity, we provide communications. And you've seen from other speakers, both in this panel and in other panels and throughout the sessions and in other one, is that ICT is an enabler to certain aspects of the smart city. It is not for the benefit of having communications or the benefit of having ICT, but how do we use ICT to enhance quality of lives, to save lives, as the gentleman from Medellin says, they use it to save lives. And this technology platform, and this is the area that we specialize in at Cisco, needs to be resilient enough in order to sustain these types of activities. Not only because of critical infrastructures such as safety and security and transportation and so on and so forth, but also when you get used to a certain quality of life, a certain way of doing things, you don't want that to go away all of a sudden. So the platform, in our terminology, we have something called the network as a platform. And if you've heard other Cisco talks before, this was one of our mantra, is when you start connecting things, you can start having smart ideas. And we don't have all those smart ideas. We work with a lot of partners and a lot of companies, a lot of innovators that develop those smart ideas. But the connectivity enables that. So once you have that connectivity, you start having smart things. So normal energy becomes smart grid. Normal education becomes modern education, and so on and so forth. And cities become what we call smart and connected communities, which is the term that we use to define the smart city. And once you get used to this type of life, as I was saying, this type of way of doing things, it is very difficult to go back. And unless the platform that you build is resilient enough to manage both natural disasters, as you were saying earlier, as both man-made disasters, it will be very difficult for the citizens and for visitors and everybody that lives in or around that city. This layer of connectivity also allows interaction between different systems. So your buildings are communicating with your transport, your utilities are communicating with your education department. Safety and security is a key aspect. So as I was saying earlier, you're carrying both critical infrastructure material as well as lifestyle and quality of life material. So this is how we view the world. This is how many companies in the industry that I work in view the world. And we've seen a very similar one from Mirko in Abertis. It's just a different way of looking at things. So at the bottom layer, we see what's called the sensor layer. And sensors are sensors that detect temperature, humidity, noise, presence, if you're talking about a parking application, traffic flow. Cameras in our world are types of sensors. They're video sensors. They sense certain activities. There's an interesting one you'll see down there is people. And I showed this to someone before, and I said, how can people be sensors? Isn't it really objectifying things a little bit? But in our terminology, we use the term Internet of Everything. You might have heard of the term Internet of Things, which connects different things, which is the sensor part. The Internet of Everything adds, and I heard the gentleman from Medellin, people, it adds processes, and it adds data. And when you have a combination of all of these things, then we believe you have the essence of a smart city. So the people, and we heard Twitter, and we heard other social activities, when you send a tweet, or when you make a post to certain Facebook pages, or any of the other social media and the social networking applications, we can use that as an input, as a data input that can be used in addition to sensors or in lieu of sensors in order to make decisions. So there are many countries out there in the world. In the UK, for example, they're doing this, whereby there's a portal and you can take a picture of an accident or a pothole or a broken street light or whatever, and you upload it to the portal, and then the city can then use that information to take remedial action immediately without having someone to actually complain or a maintenance crew to go and detect these types of activities. So we detect all of the different activities that we have in the city or in the community, as we call it, and we have the term now of big data comes, of course. So all of these sensors, all of this data input points, all of these people are sending data. They're sending data. Megabytes and megabytes of data go into the network, this big data. The challenges, of course, is how to take that big data, how to take that data, these elements of information, and make sense out of it. So how to transform data into information. How to transform data into intelligent or relevant information. And then obviously at a higher level, which I'm going to go into in a minute, how to take that relevant information and make informed decisions out of it. So this is where the middle layer comes in, and we split it into two, again, just like the gentleman from Abertis Telecom. There is let's say the physical aspect, which is the transport. So these are your transport mechanism, your access points, your different devices that are used to connect something from point A to point B. The top layer is where most of the intelligence happens. So you see your analytics, your processing, if there's a billing aspect to it. So for smart parking applications, for example, has an immense billing aspect, and has been one of the main drivers why a lot of cities that we work with decide to go down that path because of parking revenues. A lot of people, especially in Europe, in Germany, especially where I live, where the fine is €5. Well, now it's 10. If you park, instead of paying the €2 or €3 to park, you'll risk, maybe I'll get caught, maybe I won't, and pay the €5. So the parking revenue was key. So there's a revenue aspect there as well. And then we have the APIs and SDKs. which then expose that information for partners, developers, entrepreneurs, startups, and so on and so forth, to develop applications. And you can see all across. So the city, obviously, by city operations, and inside there you see, you will find many different things. But you also have, manufacturing applications, mining applications, energy and utility and smart grid applications, transportation, whether it's parking, traffic, and so on and so forth, as well as the M2M world, the machine-to-machine world, so in the industrial space and the rest of the manufacturing space. So all of that sits on this information. Now, this middle layer is our platform. So it is the ICT platform that drives those applications, that takes the information from the sensors up to that application layer, and if decisions need to be made, they need to go through that platform again. Now imagine if that platform were to fail. That means the smart city will become a dumb city all of a sudden again, Professor, as you were saying. And we've heard from the professor is dumb cities will not be able to sustain themselves in the future. So this is why when we work with the cities and the communities that we work with, we make really sure that this platform is extremely resilient. And in the ICT world, we have a lot of experience in doing that. So large banking institutions, and I know it's a totally irrelevant industry from the city perspective, or completely different, I should say, not irrelevant, or the manufacturing industry, if their communications infrastructure fails for mere seconds, it is millions, sometimes billions of dollars lost. So for these types of environments, we build very resilient infrastructures that cater to natural disasters. So if there's an earthquake or something like this, there's a backup that keeps all these systems running simultaneously. So we look at the same type of infrastructure here when we look at the platform that supports all of these services. They need to be extremely resilient. So in addition to other networks that, from the past, such as electric grids, transportation networks, water networks, sewage networks, as well, we look at providing this, what we call the digital overlay. So digital information or digital connectivity is available in all places, and it needs to be, again, resilient, because you have things like hospitals on there that connect to the utilities company, for example, that connect to other healthcare provider entities and so on and so forth. Imagine if the connectivity or the platform that connects these two were to fail. Lives will be lost. So we work all across the world, so we are a global company, but we have chosen a number of cities or entities around the world where we put in most of our focus. One of them is Barcelona here, so we do a lot of work with the city of Barcelona, also in collaboration with Abertis Telecom, who's one of our partners here, but is how to enable the smart city. And no city does everything at once, so don't expect to see an example of a completely smart city that does everything. Also, the definition of a smart city, as you may have gathered through the last, 7, 8, 10 years, that the term has been around in its various forms. There's no standard yet that the world agrees on what is a smart city. So different people use different. So in Rio, for example, it was more based around safety and security, and we worked with a number of partners there. In London, it was very specific, where we built the platform to support the 2012 Olympics. Again, you have billions of dollars going into media and so on and so forth that we're running on the platform, and that needed to be extremely resilient. And there are specific areas of activities that we work on in different cities as well. So in the lighting space, we have some projects going on in Amsterdam. City 24/7 is more of a, it's based a lot on media. It's about informing citizens of activities, but also political campaigns. And it's an interactive system where the citizen can go in and get information. Basically, the old phone booths that are new, nobody really uses them anymore. So the plan is, it's still in its early days, but the plan is to, instead of these phone booths, to put these smart type kiosks that allow interaction between the city and the citizens. In both Nice and here in Barcelona, we've done the first pilots of what we call the Internet of Everything, where we do things. Some of you may have been on a smart city tour, so some of these things are powered basically by some of our equipment. So you might have seen the smart bus station or the intelligent bus station. You might have seen the intelligent waste management, the intelligent parking. All of these things run on a platform. And I was saying, obviously in the pilot phase, it's still a small deployment, but once it goes across neighborhoods or whole cities, the platform that supports it needs to be extremely resilient. Otherwise, you lose the way of life and the critical infrastructure goes down, which is something we definitely don't want. Final thing, yep. The final thing, so it's a number of things. I've mentioned these in going. So standards are important, not always feasible, but very important. Regulation is an issue that the professor and I were talking about earlier before the session. Some of these things require regulation, especially as you start breaking silos, as you said, Professor, and so on and so forth. PPPs, extremely important. And for us, the ecosystem, nobody does it alone. Academia, different cities that are willing to experiment things, operators, and as well as innovators need to collaborate in order to deliver on that promise. And that's it. Thank you very much.